All right, the simplest form of a radical. The simple form of a radical, basically what we're asking you to do is simplify it. Okay, so for example, if we did, this is what we did back in square root. So if I had like the square root of 24, well that's 4 times 6, which I can take the square root of the 4 and leave it as 2 on the square root of 6. Okay? We did the same thing, but just with square roots. But we're going to do it now with like 4th roots and 5th roots and 6th roots and 7th roots and 8th roots and others. So like, let's do the 3rd root. For example, if I had the 4th root of 48. Well, 48 just so happens to be 16 times 3. And the 4th root of 16 is 2. So it's 2 on the 4th root of 3. That's what we mean by the simplest form of a radical. All right, that's what we mean. I'm not saying the process is simple. That's just saying that's what they're looking for. A conjugate, you've actually already dealt with a lot of conjugates. All right, anytime you saw like it's an x plus y and an x minus y. I mean, we may not see x and y, but it's some. Oh, it stopped on me. Just a second. Okay, we're back. A conjugate is when you have basically 2 binomials, but one has a positive in the middle, one has a negative in the middle. You've already dealt with this with imaginaries, like 2 plus 3i, 2 minus 3i. It's the same thing with a plus or minus, an plus and a minus. Oftentimes we write it like this, 2 plus or minus 3i, because those are conjugates of each other. Come on, ladies. Let's go. They're 2 plus or minus 3i. But we're just dealing with radicals now. So, for example, and what we're dealing with, so like 2 plus the 3rd root of 7 and 2 minus the 3rd root of 7. Those are conjugates because they're essentially identical except for the plus and the minus. So again, oftentimes we write it as 2 plus or minus the 3rd root of 7. But that's the conjugates are one of those, if I actually gave you a verbal definition, it would probably confuse the ever-living mess out of you. It's easier just to give you some examples and say, this is what we mean by it. Okay? Like radicals. Like radicals are like terms. Okay? They're like like terms. Like cha. All right, so for example, if we have 2x squared plus 4x squared, those are both x squareds. They are like terms. So we can say that is, how many x squareds is that? 6x squared. Good. Almost forgot the squared. We can do the same thing with radicals. So let's say I had 2 on the 5th root of 7 plus 4 on the 5th root of 7. Those are like radicals. They are both the 5th root of 7. So I can combine them to say 6 5th root of 7s. Cool? That's what we mean by like radicals. You would subtract it, it'd be 2 minus 4, which would be negative 2, 6th root of 7s. That make sense? A good question. Cool? All right, so that's just a little bit of verbiage that we're going to get out of the way. Down here, properties of rational exponents. And now these are just straight properties of exponents in general. And you do not need to memorize these names at all. I forget which one, because it's like product of power, power of power, power of product. I can't even say these 10 times fast, let alone differentiate between the 3 of them. But here's basically what we mean. A product of powers is basically if we have the same base, x to the 4th times x to the 5th. Those are the same base. They're both x's. So when we multiply them, we add the exponents. So that's x to the 7th. No, not the 7th, because 4 plus 5 is obviously 15. It's 9, we know it. That's a 9. And I'll draw some lines in here so we can separate them up.
Instead of multiplying, you add them?
You add them. If you're multiplying the bases, you add the exponents. All right? Yeah, adding the exponents is multiplying those bases. The power of a power, what they mean by that, again, let's say you have something like x to the 4th. Let's write that a little, I got to zoom in or else I cannot write these clear at all. X to the 4th to the power of 5. I have an exponent to an exponent. Therefore, I need to multiply those exponents. So that's x to the 20. Okay? That would be power of a power. Okay? The power of a product. Okay, so this is basically if you've got something that looks like this. Let's say I have an x and a y. All of that's to the fourth. Now, there's no adding or subtracting in the middle. There's nothing like that. They're just straight up, everything is multiplying.
Is x squared or x?
20, thank you. Thank you very much. That's a 20. Basically, what I can do is I can distribute that 4 to both of the exponents. So, again, those are both 1s, right? So 4 times 1 is 4. That would be an x to the 4th times a y to the 4th. And sometimes, you can go either way. Sometimes you're here and you need to go over here. Sometimes you're on this one and need to go over that one. So they both have their uses. But the fact is, the idea is we can go back and forth. Okay? Negative exponent. We talked about negative exponent yesterday. So example, if I have x to the negative 2. That negative exponent, I do not have a negative x. What is that exponent telling me to do? What about? It's still an x squared. It goes where? It goes down. It goes to the denominator. So it says, hey, I'm on the wrong side. I belong in the denominator. Cool? That's all the negative exponent means. Now, if it's already in the denominator, it means, hey, I actually belong in the numerator. All right? The opposite is also true. So we can go back and forth. It just means, hey, I'm on the wrong side. Zero exponent. You already know this one. You just may not have thought it. Anything to the 0 equals what? No. 1. Which you knew that. You just forgot and hadn't seen it in a while. Okay? It's just been a while. Anything to the 0. Now, if somebody asks, what about 0 to the 0? Honestly, it might still be 1. I don't know. All right? But that's one of those weird cases of, yeah. Hello, ladies. Let me pause this. Anything to the 0 is 1. It doesn't matter what it is. It could be the craziest, like, oh my God, this is the worst thing I've ever seen in my life, to the 0. Well, that equals 1, no matter what's in there. Okay? Yeah, and that squiggle is a technical term, so be sure you copy that squiggle down perfectly. 0 exponent. Quotient of powers. Okay, this one's a, what if you have something like this? Let's say you have x to the 4th over x to the 3rd. Okay, so if we are multiplying those bases, we add the exponents, right? So if we're dividing the bases, we subtract the exponents. So that would be x to the 4 minus 3, which would be just an x. Remember, the 1 is understood. You don't have to write it, but it is there. Last but not least, power of a quotient. Why we have 2 rules for this? Honestly, I really don't think we have this many rules. We've labeled the rules. I don't think they've been labeled. I just think the book says, hey, we gotta call it something so we don't confuse the kids. That's probably what's going on. But anyways, so remember up above? Okay, Mr. Hunter. Okay. All right, so here we go. Power of a product. Remember this one right here? I could distribute that to both the x and the y. Well, just because they're in a fraction doesn't mean I can't do the same thing. That's still x to the 4th over y to the 4th. Cool?
So you multiply 1 times 4.
Yeah, this is x to the 1. So 1 times 4 will give me 4. Y to the 1. And so just to kind of, if I were over here, let me give you a brief exponent. So let's say I had x squared y cubed over z to the 4th. And I had that all to the 5th. Well, that would become x to the 10th, y to the 15th, z to the 20th, which is a little extreme, but do you see where I'm going with that?
No.
Okay, so that's okay if you don't. Basically what I did is I went over to my power product, and these are the same thing. Just one there multiplying and one there dividing. I basically took the exponent and distributed it to all the other exponents. So 5 times 2 is 10, x to the 10. 5 times 3 is y to the 15th. 5 times 4 is z to the 20th. That's what happened. Cool? That's all that is. All right, let me erase this because. There you go, it's back. Where did I get the 20? Remember I did 5 times 2, 5 times 3, 5 times 4. All right, this is just kind of an extreme example. Well, not too extreme, but it's It's just an example of what's going on with those. Cool? All right, turn the page. Let's get through this. This is actually kind of a long lesson because there's just a lot of ways to apply it. They're not necessarily difficult. It's just a lot of things to look at. Okay? So I can delete both of those now. Oh my goodness. All right. It's very similar to yesterday, yes. So here we go. Use the properties of rational exponents. So here we go. We got the same base. So when we're multiplying the same base, what do we do to the exponents? You add them. So I got 1/4 plus 1/2. Just to add fractions, you have to have a common denominator. So that's 1/4 plus 2/4, which gives us 3/4. And since I cannot take the 4th root of 7, remember from yesterday, this is actually a 4th root. I'm just going to leave it like that. Cool? Cool. Try letter B. Try letter B. I'm not going to move it, just leave it there. Here we go, let's put it up there.
Oh, snap.
Here we go. That's cool. If you got to the 13 to the 36, that's good for the time being. On the test, you need to reduce. But I'm glad you got that far right now. Okay, so that reduces down to 13 to the 1/2. Okay, it's the exact same thing. Cool. You don't still get what? All right, do you understand that we added the exponents?
Yeah.
Okay, if I'm multiplying the same base, the rule is if I'm multiplying the base, I add the exponents. That's the rule from the other side. And from here, it's just adding fractions. That's all that is. And that is a problem we need to discuss. What's up? Sure. All right, so letter C. Letter C. Do we have the same base here? So can I combine those? No. All I can do is say, hey, I have exponents all raised to another exponent, so I can distribute the 2. Okay? So what's 2 times 1/2? 1/2. Well, I'm going to write it as 2 halves, just so everybody follows along. If you want to go ahead and write 1, that's fine. 2 times 1/3 is 2/3. Remember, if you're multiplying the fraction by something, this 2 times the numerator. 2 times the numerator. And like y'all said, 2 divided by 2 is still 1, so it's 6 times 4 to the 2/3. And that's your answer. Cool. Try letter D. Because these have different exponents, this isn't really a 4. This is a 4 to the 2/3. So this is like the cube root of 4, which is like 1 point something forever times 2. So it's actually simpler to leave it like this. Okay? Try letter D. What do you mean? Are you talking about like which one to put on the right versus which one to put on the left? It doesn't matter. Okay, 5 times 1/4. 5 times 1 is 5. So 5/4. Okay. How do you multiply? Okay, it's 1/5 times 5. I'm gonna do it on this. So here we go. Let's do it over here. 5 times 1/5. What is 5 times 1/5? 5 times 1 is 5. 5 times 1/4. 5 times 1/4. 5 times 1 is 5.
I get that, but
Today.
You're talking about, give me a second. Are you talking about this one? Or okay, you're talking about this one.
No, I'm talking about the one you're talking about. But how do we know that it's 5/4 on the other side equal?
Okay, how do I know it's this one? How do I know it's this?
The other one.
Why did you put that? Yeah.
Why did I put 8 to the 5/4?
Yeah.
Because this is an 8 to the 5/4.
But so why did you put the fraction?
Why didn't I put it for the 5?
Yeah.
Because what's 5 divided by 5? 1.
Oh, okay, never mind.
All right, cool. That's fine. It just took us a while to get that answer. Yes, Maria, you've been very patient. Thank you.
Okay, so for the 5/4, you know how it turns into 1/1/4?
Yes.
Would that affect it at all?
Okay, so what you're saying is leave it as, you want to leave it as what they call a mixed number. Okay, you know why it makes you uncomfortable? Is because in elementary school they called these improper fractions. There is nothing improper about these things. They are so much easier to deal with than a mixed number. It's not even funny.
Okay, so what happens if the mixed number does it affect it at all? Or can you write it 8 to the 1/4?
If you want to write it as 8 to the 1 and 1/4, that is okay. I would wish that you get over that, like graduate from that and do the impropers. Okay? No, it wouldn't. Here, okay, let me just give you a brief. Here's why I like mixed numbers. I like mixed numbers better, or improper fractions better. Okay, if what is 3 to the 2/4 plus 4 to the 1/4 plus 8 to the 3/4 plus 9 to the 1/2. Versus having 14/4 plus 17/4 plus 8 times 4 is, what's 8 times 4? 24, 27/4. Which I know this is a little crazy, but you notice how the denominator is already taken care of?
Yeah.
I can just add the top. You follow me? And the same way with multiplying. I don't have to return them back. So to deal with a mixed number, when you have multiple things going on, is actually more work. Because you have to turn it into an improper fraction in order to do something with it. You follow me? That's why. If you leave it as a mixed number, I'm not going to fight that. It's right. I'll leave it. But, anyways. All right, what you got over there, man? What's up, Jason? When he comes back. All right, here we go. What letter are we on? We are on letter E. Okay, so here we go. What's up? Sure, that's fine. We can start a line. So here we go. Are these the same base? So can I combine them? No. Okay. They're both being raised to the negative 1/5. So distribute it. What is 5 times 1/5?
It's 1, but it's negative something.
It's 1. You're right. I'm going to write negative 5/5 so we're on the same, but it is 1. You're absolutely right. Again, 5 times 5/5 is?
3/5. Let's go.
Because it's 5 times 1. Which you're right. Both of those turn into a 1. But remember, what does a negative exponent tell you? It is on the wrong side. Again, we got to flip it. So we got a 4 times 3 on bottom. What's 4 times 3? 12. That's your answer. Move on to letter F. Do letter F. Easy peasy chicken greasy.
Yeah, why does it gotta be chicken?
So it's gonna be both.
Yeah, they both turn into like a 12 to the negative 1, 9 to the negative 1. So you just shove them bottom and multiply them by each other. Cool? Cool. Okay. How are we doing so far? Give me a 5 to 1. 5, I got this. 4, I'm okay. 3 and 2, I'm lost. 1, save me. Yeah, I know you're like that, man. It's okay. You'll survive. All right. A couple people are still writing. So let's look at letter number whatever. G. Oh, G. All right, so G is dividing. Okay? Letter G is dividing. So if you're dividing the same base, what do you do to those exponents?
Subtract.
You subtract. So that's a 1 up there, right? So 1 minus 1/3. What's 1 minus a third? 2/3. So that's 1 is a 3/3 minus 1/3, which is 2/3. Done. Do letter H. Cool. Now, I will say this. No, my point is, if you don't need to write this part down to know that 1 minus a ninth is 8/9, I really don't care if you write this step down. But if it doesn't automatically come to you, quickly come to you, change the 1 to a 9/9 and look at it that way, because that will quickly come to you. I'm all about, if you have to write more to use your brain less, do it. Write more, use your brain less, you get further in life.
That's true.
Work smarter, not harder. Cool? All right, let's keep rolling. How to what? You don't get what? All right. Do you understand this first piece right here? No. Okay, these are the same base, right? So we're going to subtract the exponents. Just like if I have x squared times x to the fourth, we would add those exponents, right? If we're dividing, we subtract those exponents. So x squared, x to the fourth, it would be 2 minus 4. Okay? So this is a 1 minus 1/9. And then from there, it's just fraction rules to get back to there. Cool? That's all it is. Erase. All right, letter I. Okay, cool. We actually kind of already done one like this. Those are different bases, so can we combine them? No, but what can we do to the two? Distribute it. Technically it's not called distributing, but we can multiply all of the exponents by 2. So that's 42 to the what? 2/3. Divided by, and that's a 3, believe it or not. 6 to the?
2/3.
Good, you're done. Do the next problem. For real.
I thought you said I was dumb.
I am not denying that, but that is not what I said. That's all. It happens. All right, do K and L. Do K and L. All right, do K and L. Yeah.
I forgot to add. Where'd you get the 3 from? To get 5.
All right, what's up?
Oh, I did get 5 4.
How did I get 5 fours?
Oh, you added it. Never mind.
What's 3 plus 2?
I know.
It's all right.
Oh, I see.
All right, so here's my question on this. Once you kind of knew what you were doing, how long did these really take you to do?
30 seconds.
Not even 30 seconds.
5 seconds.
Probably more like 10 at the most. Some of you 20, some of you 5, but somewhere between 5 and 20 seconds to do each one. Okay, so the reason I say that is when you see your homework and it says 3 to 40, understand that is not because it's going to take you 3 hours. No, it's not going to take you 3 hours to do. What we're trying to do is we're trying to dig that rut so that you're not even thinking about this stuff anymore. All right? I would like you to be the place to where you see this and you just go, oh, I do this. You don't have to think, do I have to add these? Do I have to, you just do it. You follow me? It's kind of like doing a layup. You do them over and over and over and over and over until you're blue in the face. And then finally, I can do it without thinking about it. All right? That's what we're trying to get to with these things. Cool? All right. Turn the page. Let's keep rolling. Let's keep rolling. The product property and the quotient property. Okay, product property basically says if I have the third root of x times y, I could break that up to the third root of x times the third root of y. Okay? I can break them up like this. Or I can combine them if I need to. If they're split up, I can bring them together, but they have to have the same root. It can't be like a third root and a fourth root. They've got to be the same. Quotient property. Hey, that one's so different. You ready? If I have the third root of x over y, and I'll split them up so that no one's confused. I can break that up to the third root of x divided by the third root of y, which that's not a 4, that's supposed to be a y. Cool? So I can break those things up if I need to. Or combine them if I need to. Whichever. All right? So here we go. Problem 2. Here we roll. Like number A, letter A. Number A, whatever. I've had so much sugar today, it's not even funny. Like, my ADD is going nuts. The only thing holding me back is the coffee. And I mean that. Coffee is delicious. So these are both, those are both third roots, right? Which means I can write it like this. I can go the third root of 12 times 18. Which everybody knows the third root of 12 times 18 is what, 216?
Yeah.
Somebody knock in their calculator.
It's 260.
No, you don't. You don't know that.
12 times 18 is 260.
Is it? Cool! And I'm pretty sure that the cube root of 216 is actually 6. Is it?
Yes.
Cool. So you took your calculator, went 216 to the 1/3, and it gave you a 6. So this, while I cannot take the cube roots of these individually, when I combine them together, they reduce all the way down to a 6. Okay? Letter B operates in the same fashion. I got 80 over 5, so I can bring that together and go the fourth root of 80 over 5. Not 84 over 5, 80 over 5. Which everybody knows 80 over 5 is 16, right?
Yes.
Totally. Which, what's the fourth root of 16?
4.
2. Cool? If you didn't know 80 divided by 5 was 16, that's fine. I didn't expect you to. You can just put it in your calculator and go. But that's what it reduces down to. All right? Cool? Are you right over there, Mary?
Who would it be?
Did you hear all that? Don't repeat that.
No, I'm recording, so don't repeat that, whatever it was, okay? Yeah. So, do C and D. Do letter C and letter D, okay? So here we go. What you got? Here, I gotta. That's one of the problems going to the bathroom. You gotta get yourself caught up, which I may eventually, but not right this second. All right, so where did I get the 512? 4 times 128 is 512. And you can shove that in your calculator. 512 to the 1/3 will give you 8. Okay? Same thing over here. 192 divided by 6. 32. All right, how are we doing with this? Give me a 5 to 1. 5, I got this. 4, I'm okay. 3, and 2, I'm lost. 1 save. Sweet. Okay, so this is where we start combining things a little bit. Okay? It's not that bad, but you just kind of got to get used to the process. It says write in simplest form. Okay, so first things first, I cannot take the third root of 135. I can't, not evenly at least. So what I'm going to do is, remember when we did stuff like this, we did the square root of, let's say, 48, and we realized, oh, that's 16 times 3, and the square root of 16 was 4, so that's 4 in the square root of 3. You remember that, vaguely?
Yes.
That's essentially what we're going to do. But you don't need to memorize all your perfect cubes and your perfect fourths and your perfect fifths and your perfect sixths. So here's what we're going to do. We're going to start with something big. So let's start 6 to the third power. Divide it by 6 to the third power. Literally type 135 divided by 6 caret 3. Just like that. If it comes out, does it come out to a whole number? Do you get a decimal? Yeah, okay, so let's try 5 to the third. Do you get a decimal? If so, try 4 to the third. If so, try 3 to the third, and keep on trying. I know I'm going faster than you need to.
3 to the third, that's 5.
Okay, it's 3 to the third times what? times 5. So here we go. This 135 is...
Yeah, why did you start at 6?
It was just something big. I knew it would be too big. Because 6 to the third is 216. I know that's not going to go into it. I know. I understand that, but
What if we start at 12?
if you start at 12, that's way too damn big. You're absolutely right. All right. So that's 5 to the third time. 3 to the third times what? 5? Is that what it was? So here's the deal. This exponent will cancel that out for the 3. So the 3 comes out, and the 5 stays behind. Cool. That is how you reduce these things, or simplify them, however you want to say it. Cool. All right. So that's that part. The next part has to do with rationalizing the denominator.
So the 3
Le-
get out?
Yes, because the 3 is cubed, we have a 3 to the third power. The third root of 3 to the third power is 3. The root and the exponent cancel each other out. And I'm just left with the 3. But it doesn't cancel it out for the 5. The 5 has to stay behind. Cool? Letter B. Okay, so it is considered highly, highly improper, big math boo-boo, to leave a radical in the denominator. Because fractions are interesting enough to deal with putting weird stuff like this in there. All right? So here's what we're going to do. This is an 8 to the 1. Right? So in order to get rid of that radical, I have to have an 8 to the 5. So how many more 8s do I need?
3 more. 4.
4.
Oh, really?
So here's what I'm going to do. I'm going to multiply. I'm still going to multiply it by a 5th root, but it'll be an 8 to the 4th. Still going to do the 5th root, but an 8 to the 4th, because these combine to the 5th root of 8 to the 5th. Everybody cool with me still? All right, last but not least, those cancel each other out. And you're left with an 8 on bottom. Because the 5th root of something to the 5th just cancels each other out. Like if I square something and then square root it, if I raise it to the 5th and then 5th root it, they cancel each other out. Okay, we'll get to that. So everybody cool with the bottom? Okay, one of the big rules of fractions, whatever you do to the bottom, you got to do to the top, right? So here we go, let's do the top. I'll change colors just for the fun of it. Let's do green. So I still have to put a 5th root of 8 to the 4th. And this is kind of where we combine the last one. That's what we put on bottom, right? Whatever you put on bottom, that's what you got to put on top. Does anybody know why you do the same thing on top to bottom? Would you like to know why? Okay, so if I multiply by 4 on the bottom, and I multiply by 4 on the top, what does this fraction reduce down to? 1. So I've multiplied it by 1. Good. Have I changed the actual value of anything? No, I've simply changed the way it looks. That's why the bottom has to match the top. So here we go. Let's keep rolling. Remember, I can combine these two. So that's the 5th root of 7 times 8 to the 4th. So okay, you see where we're going with? Now, take your calculator and multiply that out, and you are going to get a friggin' huge number, like 28,000 something. What do you get? Okay, 28,672. And this is where we start reducing that sucker. So start off with, we have an 8 to the 4th over here. So start off divided by 8 to the 5th. If that gives you a decimal, try 7 to the 5th. If that gives you a decimal, try 6 to the 5th. And then 5 to the 5th. And then 4 to the 5th. I'm going to give you a hint. 4 to the 5th is the one that works. So take 28,672 and you would just try those. But then you get down to 4 to the 5th. And it spits out a 28, right? So, we've got the fifth root of 4 to the fifth times 28 over 8. All right, we ain't done yet. So what number comes outside, the 4 or the 28? Ooh, what comes out? The 4 and the 28 stays in. There is one more thing you can do. Reduce the 4/8 to a 1/2, which leaves 5 root 28 over 8. We will pick that up tomorrow and do this again. I am staying after school today.
Can I come?
Sure.